For section 7.4, we will do two videos. In the first video, we talk about partial fractions. In the second video, we talk about the trigonometric substitutions, that is, substitution of sine theta or tangent theta. So now let's talk about the method of partial fractions. This is a method for rewriting certain rational functions in a way which makes them easier to integrate. So now let's look at an example. Find AB for which 1 over x minus 2 times x minus 5 is equal to A over x minus 2 plus B over x minus 5. For this example, we want the left-hand side is equal to the right-hand side. So now let's observe the right-hand side. So for the first one, its denominator is x minus 2. The second one, denominator is x minus 5. So we want to put the right-hand side over the same over common denominator. So we have 1 over x minus 2 times x minus 5 is equal to, so the common denominator is x minus 2 times x minus 5, right? So for the first expression, we multiply both numerator and denominator by x minus 5. Plus, for the second one, we multiply both numerator and denominator by x minus 2. Now they have the same denominator. We only need to add the numerator together. And the left-hand side, we copy it. So next, we want to get rid of the denominator. So we multiply both sides by the denominator x minus 2 times x minus 5. So have 1 is equal to A times x minus 5 plus B x minus 2. Next, we remove the parentheses for the right-hand side. So it's ax minus 5a plus bx minus 2b. So next, we group the x term together. So this is a plus b x. Then group the constant term together. So we have this one is equal to 1. So now the left-hand side and right-hand side are both polynomials in x, and they are equal if and only if the coefficients of the different powers of x match. So for the right-hand side, the coefficient of x is a plus b. So we have a plus b is equal to the coefficient of x on the left-hand side. The coefficient of x on the left-hand side is 0. Right? There is no x term. Then we look at the constant term. So the right-hand side, the constant term is minus 5a minus 2b. On the left-hand side, the constant is 1. So we have these two equations are equal. Now we label this as 1, this as 2. So from 1, we have b is equal to negative a. Then we substitute b is negative a into a. So we get negative 5a minus 2 times negative a is equal to 1. So this is negative 5a plus 2a is equal to 1. Negative 3a is equal to 1. A is equal to negative 1/3. So from here, we know b is negative a. To have b is negative a is 1/3. So we have a is equal to negative 1/3, b is 1/3. So that is 1 over s minus 2 times s minus 5 is equal to negative 1 over 3 s minus 2, then plus 1 over 3 s minus 5. So this is example 1. So now let's see why this is so useful. We look at an example. Integrate 1 over s minus 2 times s minus 5 dx. So from example 1, we know this integrand is equal to the sum of these two fractions. So we can rewrite this integral as integral negative 1 over 3 s minus 2 plus 1 over 3 s minus 5 dx. So this is the integral of the sum of two functions. So it's equal to the sum of two integrals. It's integral negative 1 over 3 s minus 2 dx plus integral 1 over 3 s minus 5 dx. So for the constant, we can take them out. So this is negative 1/3 integral dx over s minus 2 plus 1/3 integral dx over s minus 5. So this is equal negative 1/3 ln the absolute value s minus 2 plus 1/3 ln the absolute value s minus 5, then plus the constant c. Since this is the indefinite integral, don't forget the constant c. Then we finish this example.